Alright, in this video I'm going to do a couple more examples of substitution or U-substitution integration. And here we've got 2x times x squared plus 4 to the power 7 dx. For those who don't know U-substitution, it's basically what I'm going to do here is kind of do a relabeling scheme. So I'll call the stuff in the on the inside, I'll call them u, just temporarily, plus 4, x squared plus 4, and now I'll take the derivative of u. So obviously I'm going to have to take the derivative of the other side as well. So derivative of x squared plus 4 is 2x dx, right? Notice that what we're doing here in this step is just calculating a differential. So du equals dx, 2x dx. Notice that we've got here is actually the leftover of the original integral. Again, after replacing x squared plus 4 to the power 7 with u, we're left with 2x dx. So we can rewrite this, the relabeled u, to the power 7, and replace 2x dx, the leftover, with du, because that's actually what du is equal to. So I'm going to put du instead, and now it's just a lot easier now to solve. It's just normal integral. So the integral of u is to the power 7 is, as you know, we add 1 to the power, so it's going to be to the power 8, and we divide by the new power. Sorry about that. So that would be u to the power 8 over 8 plus c, don't forget our constant. And now what we basically do, we're going to put back our original what u is equal to, like here, right? So we're going to plug it back in. So that would equal to, so instead of u, put x squared plus 4 to the power 8, the new power, over 8, and then plus c. And that's our integral. Also another example, just to make sure that we understand it properly. Alright, if we take this example, it says cosine of x to the power 4 times sine x dx. Well, the first thing we notice is that we know that the cosine and sine are derivatives of each other. Well, at least one of them is a negative derivative of the other. But anyway, it makes it kind of easy to solve. And the thing is, usually whatever something is that is raised to a power and is between parentheses, that actually usually most of the time is u is equal to. So in this case we're gonna make cosine to the cosine x is u, cosine of x is going to be u. Now again we take the derivative of u. So derivative of the cosine is minus sine x dx. And notice again we've got minus sine x dx and we've got sine x dx in the original one. What we can do is just it's actually the same except for the minus, so we can pull the minus on the other side. So it's going to be du equals sine x dx. So now we can substitute minus du with sine x dx and write the whole thing again as it is. So let's rewrite this. So we've got the integral of, well, we're going to put u here because we replaced that with u, right? So that's going to be u. Cosine x, we'll replace it with u, raised to the power 4. And then instead of sine x ds, we're just going to put minus d, right? So times minus du, sorry, not du. And now we just got a just normal integral, easy integral problem. What we can basically do is just pull the minus out as a -1 outside the integral. I'm going to put it later. And now we've got u to the power 4 du. And now we can just take the integral. So u is going to be to the power 5 and divide by the new power and then plus c. And obviously we can plot in the minus now, so it's going to be minus u to the power 5th over 5 plus c. So now what we basically do is we're just going to plot the I'm going to put back what u equals to, what we gave it to. So we're going to substitute u with cosine x. So that's going to be cosine x to the power 5 over 5 plus c. Yep, sorry, looks like I forgot the minus sign here. I'm just going to put a minus sign. So yeah, that's going to be minus, by the way. Don't forget that, because there's a minus here. So I'm going to plot in u back to its original shape, which is cosine x. So it's going to be minus cosine x to the power 5th over 5 plus c. So yeah, that's the main idea of using integrating using the u-substitution. So yeah, the next video I'm going to talk about other methods, integrating by parts and partial fractions.